These are the notes for 7.5. We're solving rational equations. All right, so the first way to do this is by cross multiplying, which I really dislike that term because it's really just finding a common denominator and multiplying by the denominators. But we'll do cross multiplying, makes it nice and easy. If I take 2 and I multiply it, oh, that's really wide, and I multiply it by the denominator on the other side, so this times this, I get 2 times 2x minus 7. And then that equals, if I multiply 5 times the other denominator, x plus 8. Okay, that's what it means by cross. See, it kind of makes a cross. It goes across and multiplies the numerator on top on one side, multiplies by the denominator on the other. So now let's distribute and get rid of the parentheses. So I take 2 times 2x, get 4x, 2 times really a negative 7, would be a minus 14. 5 times x is 5x, 5 times 8 is 40. And then we're going to just solve for x. So I'm going to subtract 4x on that side and that side. So I get negative 14 equals x plus 40. Subtract 40. And I get a negative 54 equals x, or x equals negative 54. And we do have to check this, that it works, okay? So, because it always says check your solutions. The main thing you're checking for is that your denominator doesn't become 0. But you can plug in x, the negative 54, in down here and put that in a calculator and then see what you get for that side and then do the same thing. But you always have to put denominator in parentheses. And check that your two sides equal. Like I said, the main thing is to check that if you plug in for these x's, if you plug in negative 54, your denominator cannot equal 0. So, and I'm just going to tell you, because I checked it, that negative 54 works. And that is our solution for number 1. Okay, so number 2, I'm going to take x times x. I get x squared equals, and I take a negative 4 times an x plus 1. So I need to distribute on that side. So I'm going to get, a negative 4x minus 4, because negative 4 times positive 1 is negative. And then I need to solve for x. Well, I have an x squared, so we have a quadratic. I'm going to get everything to the side with the x. So I'm going to add 4x to both sides and add 4. So I get x squared plus 4x plus 4 equals 0. And this is why we practiced factoring in the Seal Builders. So I need to factor this. And I get an x plus 2 times x plus 2 equals 0. Because 2 times 2 equals 4 and 2 plus 2 equals 4. So that worked out. Then I solve for x. So if I solve this parentheses for x, I get x is going to equal a negative 2. If I solve this one for x, I get x equals negative 2. Okay, and then you plug it in to check. Like I said, the main thing to check is that these denominators do not become 0. Well, if this was a negative 1, that denominator becomes 0. And if this was 0, it becomes 0. Well, it's not. It is a negative 2. So that works out. Okay, so for number 3, we're going to cross multiply again. So I have an x plus 1 times an x minus 6 equals x minus 3 times x plus 2. Okay, we need to distribute. So I'm going to end up with x squared plus x minus 6x minus 6. And that's going to equal x squared minus 3x plus 2x minus 6. Okay, so this becomes x squared minus 5x minus 6, x squared minus x minus 6. Okay, so let's move x squared to the same side. I'm going to subtract x squared. Well, that just got rid of it on both sides. That's nice. If I add 6 to both sides, get rid of that too. So I end up with a negative 5x equals a negative x. Well, let's get x's to the same side, so let's add x. So I end up with, I'm going to have to move over here because I ran out of space. So I have negative 4x equals 0. Divide by negative 4, I get x equals 0. Now, if I plug that in for my x's, it does not make any of those denominators 0 because it'd be a 0 minus 3 is negative 3, and a 0 minus 6 is negative 6. So that does work. And then if we do number 4, let's cross multiply. Negative 2 times x plus 21 equals x minus 3 times x plus 9. So I get negative 2x minus 42. And now I'm going to do all that distributing and combining my like terms at the same time. So I'm going to get x squared plus 6x minus 27. And then we're going to solve for x. So let's get everything to the side where x squared is. I'm ending up with all these little things there. There we go. So I'm going to add 2x and add 42. Okay, so this left side becomes 0. Then I have x squared plus 8x plus 15. Okay, and then we're going to factor. So I get an x plus 3, x plus 5, 3 and 5 multiply to 15 and add up to 8. And if I set each of those equal to 0, I get x as a negative 3 and a negative 5. Well, a negative 3 for x makes neither one of those 0 because it makes the denominator on the left negative 6. It makes the denominator on the right 18. And then same thing, if I plug in negative 5, none of them equals 0. So actually this one has 2 answers. All right, so we're going to solve these by least common denominator. So I need to find the least common denominator of each fraction, all of this together. Well, remember, if it's a constant, it has a denominator of 1. So as the biggest constant, I have 7, and 1 can be divided out of 7, so I know 7 has to be in the denominator. And then I have a variable of x, so that has to be in the denominator as well. So if I need 4 over 7, that denominator is missing an x, so I multiply top and bottom by x, minus, and then I have the fraction 1 over x. Its denominator is missing the 7, so I'm going to multiply by 7 over 7. And then I have the fraction 6 over 1, and its denominator is missing both 7 and the x, so I got to multiply by 7x. So I'm going to simplify by doing those multiplications, and I end up with 4x over 7x minus 7 over 7x equals 42x over 7x. And if I multiply everything by 7x, the denominators go away, and I'm left with 4x minus 7 equals 42x. And then I need to solve for x, so I'm going to subtract 4x from both sides. So I get negative 7 is going to equal 38x. And to solve for x, I'm going to divide by 38. And then I get x is negative 7 over 38x. And that doesn't simplify, so just leave it in your answer. And so if you're entering answers in on big ideas, there's a function that has like a box over a box, and you'd put the negative 7 in the top and the 30 over that. You cannot enter it in as a negative 7 divided by 38. It will count it wrong. So if you keep getting the wrong answer, that's why you can't do that. And this does check out. You do need to check your solutions to make sure none of the denominators turn into 0, and then this one wouldn't, so that is correct. Now this next problem, I'm not going to do it with you because I'm going to do some more problems that have similar ones, but I am just going to tell you least common denominator. We consider this one term, that's one term, and that's one term. And each term has to be included in the least common denominator, so that x plus 1 has to be there and x plus 2 has to be there. Because here, this one would be missing x plus 2, this one's missing x plus 1, and then this is missing x plus 1. So you don't have to put the x plus 2 in there twice. It only needs to be in the denominator once. But let's go ahead and do some other problems. Like I said, we're going to do ones similar to that. That's why we're not doing that problem. You're welcome to do it if you want. You do get a fraction answer. but I don't think you have many fraction answers on big ideas. So let's do number 7, where I need to find my least common denominator. Okay, now to do this, I need to go ahead and factor. This right here can be factored. So that's why we practiced it in our skill builders. I can take an x out of both terms, and I end up with x times x plus 4. So that is this denominator. So I need to look in each denominator. I know I have the term x plus 4, has to be in my least common denominator. This one has just the term of x. So I have to have that in my denominator. And this has both of them. So it's already it has the least common denominator. So now I can write my fractions. I have 12 over x plus 4. That denominator is missing x, so I multiply both top and bottom by x. Minus 7 over x, so that denominator is missing an x plus 4 and an x plus 4. And then this one already has that least common denominator. Whoops, I missed my x there. Okay, so I'm going to go ahead and simplify these things. I end up with 12x over x times x plus 4 minus 7x plus 28 over x times x plus 4 equals, oops, and I missed a 2 on that one, so 22 over x times x plus 4. So again, if we multiply everything times x plus 4, these denominators go away, and I just need to concentrate on the top. So let's collect some like terms, but first you have to remember this minus goes to both of these things. So I need to rewrite this before collecting like terms and distribute that negative to both things. So I'm going to end up with 12x minus 7x minus 28 equals 22. Okay, so here's some like terms. So I get 5x minus 28 equals 22. I'm going to add 28 to both sides. So I get 5x equals 50. Okay, and then you divide everything by 5, and you get x equals 10. So you need to double check that none of your denominators turn into 0, and they do not. So that is the solution. Okay, we're not going to do number 8 just because it's just another problem, and I don't need to give you quite that many examples. But I do want to give you an example like number 9. Okay, again, this can be factored. So this is x times x minus 5. That is that denominator. So my least common denominator, and I get in the habit of always writing my least common denominator out so I'm not missing it. Like I don't forget any of the terms of it. So again, I have x as a variable and I have x minus 5. And then this one is my least common denominator, okay? So this first fraction is missing x. So I'm just going to go ahead, because we know up here, we end up multiplying by this denominator, right? And then they go away. So I know I had to multiply the top and bottom by something. So if I'm multiplying this times this, and I'm going to get rid of the denominator anyways, I'm just going to write what I know the top is. In that case, it has to be that 2, and the denominator is missing x, so it's going to multiply by x. And then I'm just kind of ignoring the denominators after that, okay? That just skips a step. So if you need to do it in the previous way, do it in the previous way. This numerator is 3. Its denominator is missing an x minus 5. So again, you would multiply both the top and the bottom by that. But I said later we're going to ignore the denominators anyways. So on top I end up with 3 times x minus 5. Okay. And then the last one, it equals, and 10, and that denominator is already the same, or is already our least common denominator. So I can just cross that out to begin with. So see, and then this would be where we normally would say, okay, multiply by x times x minus 5. Those denominators go away, and I'm left with everything on top. Okay, so I have to distribute that 3. So I'm going to distribute that real quick. Combine some like terms. So I get 5x minus 15 equals 10. Add 15 to both sides. 5x equals 25. I'm going to divide both sides by 5, and I get x equals 5. Now the thing we need to look at here, I made a lot of marks on my denominators, so I need to see if I were to plug in 5 for any of these denominators, does it give me the answer of 0? Well, if I plug 5 in here, 5 minus 5 is 0. I cannot take 2 and divide by 0, so this can actually not work. Therefore, there's no solution. That is why you're checking your answer, because sometimes mathematically you get an answer, but it actually can't work in your problem. Okay, slide on over to number 10. I don't know why it already has a mark there. We'll just... okay, now we need to factor this one. So it has to multiply to positive 4, but add up to a negative. So it'll be that. And then this denominator is gone. So my least common denominator has to have an x minus 4 in it. Has to have an x minus 1 in it. And this already has both of them. So that is my least common denominator. All right, this first fraction. So on top I have x plus 6. The denominator is missing an x minus 1. Okay, and again, I'm just not writing the denominators because we end up getting rid of them anyway. So I'm kind of skipping that step. So 30, its denominator is the common denominator, so I don't multiply by anything, equals 3, and then that denominator is missing the x minus 4. Okay, now I need to do some distribution here, so I get x squared plus 5x minus 6. Remember, you take x times both terms, 6 times both terms, okay, and then combine all your like terms. And then I still have that minus 30. It's going to equal 3x minus 12. All right, so then you have, combining some like terms here, I have x squared plus 5x minus 36 equals 3x minus 12. Now, because it has the x squared here, let's get everything to one side. So I'm going to subtract 3x and add 12. So the right side becomes 0. This side becomes x squared plus 2x minus 24. And then we need to factor. So needs to multiply to 24, but add up to, multiply to a negative 24, but add up to a positive 2. So that'd be a plus 6 and a negative 4. And then if I solve these for x, I get x is a negative 6 and a positive 4. But I have to check my answers. So if x is negative 6, let's make it so we can see all of our denominators up here in our original equation. If x is negative 6 and I plug it in, do any of the denominators equal 0? Nope, they all work. But if I plug in a positive 4 right here, that one would equal 0. So this 4 cannot work. It is an extraneous solution, but this negative 6 does work. Okay, so sometimes both answers might work, sometimes only one. And then let's go down to number 12. I know my notes have lots of different numbers on them, and you're keeping track probably, hopefully, of just keeping them in order. Doesn't matter. Okay, so here I need to factor this one. So I get x minus 4 times x minus 1. They multiply to positive 4, but they add up to negative 5. So that was this one. Oops. Let's make this get a little smaller here. So I can write down my least common denominator. I need an x minus 4. I need an x minus 1. And that one has both, so that is my least common denominator. And so this first fraction, I have x minus 2 on top. Its denominator is missing the x minus 1. Okay. And then I just don't write the denominator because we'd get rid of it anyways in a minute. So the next, this is minus 2. Now its denominator is missing an x minus 4. And then I have 12 over, and it has my least common denominator. So I don't need to multiply that by anything. All right, so let's go ahead and do all of our distributing and combining like terms. I'd get x squared minus 3x plus 2 minus 2x plus 8 equals 0. Combine some like terms. Let's see, I have x squared. Oh, it doesn't equal 0. I just realized I wrote 0. It equals 12. Sorry, I'm human. There we go. All right, negative 3, negative 2 is negative 5x. And then I have a 2 and an 8 equals 10. And all of that equals 12. Now, I'm going to solve this because I have the x squared, so let's get it equal to 0. So I'm going to subtract 12 from both sides. So I get x squared minus 5x minus 2 equals 0. Now, I could try factoring this, but if you can tell, nothing multiplies to negative 2 and adds up to negative 5. So this is where we're solving a quadratic, but we have to do it by the quadratic formula, which, if you remember, is the quadratic formula, which is negative b plus or minus the square root of b squared minus 4 times a times c, and it's all over 2 times a. Okay, and so a is whatever's in front of x squared here. This is b, and this is c. All right, so I have that a equals 1, because remember, if nothing's in front, 1 is there. B is negative 5, and then c is negative 2. So I plug them in. I get negative 5 plus or minus the square root of negative 5 squared minus 4 times 1 times negative 2 all over 2 times 1. And then we simplify this. So a negative 5 is positive 5 plus or minus the square root, and I know the bottom's going to be 2. Now with the square root, everything inside, you're just going to plug in your calculator and you get 33, which I can't take a nice pretty square root of that and get a whole number, so I'm just going to leave my answer just like that. I can tell it's not going to equal 0 because the only things that'll make these denominators equal 0 would be a positive 4 and a positive 1. Well, this answer doesn't equal a positive 4 or a positive 1, so it will work. And then that is how you get your answer. So you're ready to do the 7-5 practice on big ideas.